Okay, so we're gonna go ahead and get started. Thank you everyone for your patience, running a few minutes behind. You'll note we're using my laptop to stream the presentation, so that's why, yeah, so there's maybe some little bit different things going on. But I have the pleasure, well, first, thank you for coming out for the Rough Cut Seminar Series. I'm Matt Boone, for the Institute on Ecosystems, and I have the pleasure of introducing today Dr. Sally Moyce, who will be our speaker. I'm very excited about your presentation. So I'll give a brief introduction for Sally. She received her Bachelor of Science in Nursing from the University of Portland in 2006, and then a PhD in Nursing Science and Healthcare Leadership from University of California, Davis in 2016. And Dr. Moyce joined the College of Nursing here at MSU in 2018 and teaches research in public health nursing. Her research focuses on the occupational health of migrant and seasonal farm workers and the various risk factors for this vulnerable population. She's particularly interested in how farm work affects the health of kidneys. So let's give a round of applause and welcome you.
Thank you. Thanks. I'm delighted to be here. I really appreciate the opportunity to present to you, and I've come to a number of these sessions and have learned a lot. So I'm excited to be able to offer some of my research as part of this more global context as we talk about occupational heat exposure in outdoor workers. I also really want to thank Madison for all of your help coordinating this and getting me on board here. So thanks. My research traditionally focuses on heat exposure and the risk of heat-related illness among agricultural workers. And heat-related illness is actually a continuum of conditions that occur when the body's ability to regulate its temperature is overwhelmed. So in the occupational context, this typically happens among those who do hard physical labor in high ambient temperatures and who don't take the recommended breaks to hydrate or to rest in the shade. And it's a continuum of symptoms. So it begins with heat rash or little bumps on the skin or even a sunburn. And then it can progress to heat cramps, which is muscle cramping. If not treated, it then goes into heat exhaustion, which is when the body's temperature starts to rise. And workers might be dizzy and disoriented, feel kind of weak. And then again, if not treated, it progresses to heat stroke. And this is when the body goes into hyperthermia and the body starts shutting down. And so if this is not addressed, the worker can fall into a coma and then can even die. So in 2008 in California, a young worker was tying grapevines in a vineyard outside of Merced. And the temperature was above 95 degrees that day. And 95 degrees is the temperature at which OSHA, the Occupational Safety and Health Administration, calls it a high heat day. So a day that you're particularly at risk for heat-related illness. There was water in the fields, but it was a 10-minute walk away from where Maria was working, and the foreman didn't give their crew breaks long enough for her to go access the water. So when Maria collapsed, her fiance told the foreman, and the foreman said, "Oh, go to the drugstore and get some rubbing alcohol to cool her down and then take her home." And her fiance very smartly thought that's not really the best thing to do and took her to the hospital. And there she was diagnosed with heat stroke and 2 days later died. And it was in the hospital that the doctors told her fiance that she was 2 months pregnant. So Maria's death is not an isolated incident, and actually 3 years earlier, in response to a cluster of 4 deaths that happened very close together, California enacted emergency measures to create a heat prevention policy. And this requires employers to provide water and time for rest and shade to their employees. It also requires that employers train their workers on preventing and recognizing symptoms of heat-related illness. Despite these regulations, heat still affects the health of outdoor farm workers, especially when they perform intense physical labor in high ambient temperatures. And it's responsible for about 28 deaths per year among agricultural workers nationally. So I was part of the California Heat Illness Prevention Study, or CHIPS, which is a study run out of UC Davis designed to estimate the effects of heat exposure on the health of agricultural workers. The study occurred over 2 summers or 2 harvest seasons, 2014 and 2015, and we surveyed about 600 workers in 31 farms throughout the growing region of California. We looked at a variety of metrics, and one thing that we measured was the ambient temperature, the environment conditions. So what you're seeing here is an example from one of our days of data collection. The white line along the bottom is the ambient temperature, and it reached about 33 degrees or 90 degrees Fahrenheit. Sorry, 33 degrees Celsius or 90 degrees Fahrenheit. So a warm day, but not a hot day per OSHA standards. The black line is descending throughout the day. That's the humidity line, and that drops to about 23%. And then the red arc over the whole thing is solar radiation. And this curve represents the direct heat from the sun's rays, and it peaks between about 12:30 and 2:30. So when you're talking about measuring occupational exposure to heat, you need the ambient temperature, but you also need the physiologic response to temperature. So we took individual measurements as well. We asked each of our participants to swallow a temperature probe or a heat pill. And once that passes through the stomach, it transmits minute by minute core body temperature readings. So here is an example of one of our workers. Let's see, you can see that the temperature rises over the day, getting to about 37.9 degrees Celsius, which is about 100.2 degrees Fahrenheit. And you notice a drop right around 12:30, which is when the participant took his lunch break. Again, in the occupational setting, we're interested in how the body is regulating these inputs from the heat. And something that we need to consider is the heat generated by the workload. So the body generates its own heat in the metabolic heat load. And one way to study that is to look at heart rate. So we fitted participants with a heart rate monitor and had minute by minute readings, which are a little bit messy, as you can see. The crude heart rate is the blue, and then the smoothed is the red. And this is from that same participant. So he worked from about 7 o'clock in the morning till 5:30 at night. And you see that same dip at 12:30 when he took his lunch. And you also notice that his temperature spikes to about 150 beats per minute, which indicates some strenuous work. We also see that his heart rate doesn't return to baseline except at his lunch break. So it continues to rise and stays elevated throughout the day. So now we have a picture of the ambient temperature. We have the internal temperature of the worker and a measure of their metabolic heat load or their physiologic response to their work. So now we can look at their risk of heat-related illness. 177 people, or 38% of our sample, had elevated core body temperatures that meet the criteria for heat-related illness according to OSHA. So, this is alarming. That's a number of people who are experiencing potential heat-related illness while they're at work. But something we need to consider beyond the workplace is their homes. So here is an example of a pretty typical migrant home provided either by a migrant center or perhaps by a farm. And what you can see from this picture is some very poor insulation, poor or none, and then overcrowded conditions. So these conditions really affect the farm workers' ability to cool down at night in their home. And if they can't cool down at night, then perhaps they're coming to work the next day at an elevated baseline temperature, which further increases their risk for heat-related illness. So I'm a nurse, and I'm particularly interested in health outcomes related to these measurements. And one outcome that's part of a global story is an epidemic of chronic kidney disease that's emerging sort of along the equator, in areas where workers are doing strenuous work in high ambient temperatures. A lot of the evidence about this chronic kidney disease is coming out of Mexico and Central America. And I'm particularly interested in those countries and areas because those are the source countries for the agricultural workforce that we use in the United States to support our agricultural sector. The trouble with this kidney disease is we don't know what's causing it. And so we call it chronic kidney disease of unknown origin, or CKDU. And when we think about chronic kidney disease in the United States, we think of it as a disease of the older people, and it has with it risk factors of diabetes, hypertension, obesity, and that's it, age. But CKDU does not present that way. And in fact, it's affecting young, mostly men in their 30s and 40s, none of whom have the risk factors we might associate with chronic kidney disease, but they all seem to be involved in some way in agricultural work. Off the coast of Honduras, there is an island called La Isla de las Viudas, or the Island of the Widows, because the majority of the male population has now died, leaving an island of women to raise their families. There are a number of theories about why this might be occurring. And one of them, when you think about farm work and you think about agriculture, you think about insecticides or pesticides or other chemical exposures. Oh, these notes are not quite keeping up. Sorry. Unfortunately, we don't really have great data about pesticide exposure. It's very difficult to take a lifetime pesticide exposure risk from a farm worker. And the pesticides that they're using in some of these areas where CKDU is endemic are not actually nephrotoxic or damaging to the kidneys. So we don't have a great picture of the pesticide potential etiology of this. Another potential agent might be an infectious agent, so leptospirosis or something that might be in the soil. Again, not great data, but what we do know is that the infectious agents that occur perhaps in India and Sri Lanka are different than the ones that occur in Mexico and Honduras, and so we can't actually make a link to a specific infectious agent. So the prevailing theory is that high temperature coupled with dehydration and strenuous work is causing chronic kidney disease in these workers. And it makes sense, especially in areas where they do sugarcane harvesting. So sugarcane, when you harvest it, you actually have to burn the field in advance. And then the workers go in when the embers are still burning and start slashing the cane. So it's quite a hot working environment. Not to mention that in order to grow sugarcane, you need high ambient temperatures and high humidity. So that impairs the body's ability to cool itself down. And then finally, a lot of these nations don't have OSHA regulations. So they don't have standards of taking breaks and hydrating and resting. So a lot of factors are going into play here. And we've known for a very long time that the kidneys are susceptible to heat, especially during periods of intense exercise. So this is a study conducted in a lab setting from 1952. And there are 3 lines. The dotted line on the top, the y-axis is measuring renal blood flow. So the dotted line on the top there is men walking on a treadmill in 25 degrees Celsius, which is about 77 degrees Fahrenheit. The black line is those same men walking at 120 degrees Fahrenheit, and you can see that the renal perfusion drops. But the red line is men walking at 120 degrees while dehydrated. And you can see that renal blood flow drops by almost half in those conditions. So when blood flow drops to the kidneys, it can send the kidneys into acute kidney injury, which is a temporary condition, usually resolves within 24 to 48 hours. But we know that repeated episodes of acute kidney injury often lead to chronic kidney disease. So we believe it's an important precursor to chronic kidney disease of unknown origin. It's characterized by an elevation in serum creatinine. So creatinine is a waste product that the kidneys usually excrete, and when they aren't working properly, the creatinine level rises. We measured pre and post shift serum creatinine levels. So the participants came to us in the morning and we took a blood sample, and then they returned to us in the evening and we took another blood sample, and then tested those against some known and potential risk factors. So we had a sample of about 483, not about, a sample of 483 agricultural workers. And you can see that 83% had no injury, which is fabulous. But 14.5% of our population had elevations in creatinine that put them into acute kidney injury. So that means 70 people came to work in the morning with healthy kidneys and left work at the end of the day in acute kidney injury. And this is a silent injury. You don't know necessarily that you have acute kidney injury, and so they likely came to work the next day, had the same risk factors, and potentially went home again in acute kidney injury. We use logistic regression to model associations of acute kidney injury with some of our potential risk factors. The first thing you'll notice is that our traditional risk factors of high blood pressure, older age, overweight or obese, and diabetes were not statistically associated with acute kidney injury. Neither was dehydration, which might surprise you given what we just talked about with renal blood flow dropping. And what surprised us was that elevations in core body temperature were also not associated with acute kidney injury. So different from the studies in Central and South America, we did not find an association with heat exposure and acute kidney injury. What we did find is that vigorous workload and piece rate work are associated with acute kidney injury. So vigorous workload, when compared to moderate workload, was associated with a slightly elevated odds ratio of 1.07, and piece rate work had an odds ratio of 2.9. So piece rate work is when a worker is paid based on the amount that they harvest, as compared to being paid by the hour. And workers who work piece rate tend to be a little bit older, a little bit more experienced, a little bit more skilled. And it's a very popular method of payment because the worker gets control over their earnings. But vigorous workload suggests that there's something in the work itself that might be damaging to the kidneys. And we know a potential mechanism for kidney damage is muscle breakdown that occurs during periods of exercise or strenuous labor. And so that could be what's having a role here. We weren't able to measure that in our study, but that would be an obvious next step. It's kind of good news that these are the risk factors because these are modifiable from an occupational health standpoint. So if you think back to the OSHA, the Cal-OSHA regulations of water, heat, and shade, we can actually make a difference potentially in workers' workday, especially if we're diligent in providing rest or time for employees to rest during their workday. The thought is if we give them the opportunity to rest, the body has time to recover and doesn't incur that muscular damage that might be a precursor to acute kidney injury. So what does this have to do with Montana? Migrant and seasonal farm workers travel throughout the United States to follow crops and to look for work. And there are three routes that they typically follow. There's the Pacific route up the west, the Midwestern route, and then the Eastern route. And I did an extensive Google image search and could not find a single map that included a migration route to Montana, which is really unfortunate because Montana has a very interesting relationship to these migratory routes. So on the one hand, workers come up the Pacific side or the Western route and come into the western side of the state, so west of the Continental Divide. They come up through California, over to Washington, Yakima, and then come over and work in the cherry harvests in the Flathead Valley. Workers who come to the eastern part of the state to work in sugar beets or in our dairies actually come up the Midwestern stream. So these guys are coming from Texas. So we have two distinct groups of people coming into Montana who are working here and who are contributing to Montana's agricultural scene. Workers typically spend about anywhere from 10 days to a few months in Montana and typically go back to their permanent residence either in the South or back to Mexico. But while they're here, they are at risk for heat-related illness. These are some estimates of climate data from July. And what you're seeing here is, according to these models, a predicted increase of temperatures of about 2 degrees Fahrenheit over the next decade, over the next century. So we know that this can impact workers' health. We also know that workers can get heat-related illness when temperatures are only at 80 degrees. So even if we weren't seeing these elevations in projected ambient temperature, we know that workers are at risk while they're here. We looked at workers' compensation claim for heat-related illness in Montana from 2009 to 2018. And over this period, Montana had 303 cases of heat-related illness. Workers in the agriculture, fishing, forestry, and hunting sector were the most affected, with a rate of 27 cases per 10,000 employees. And I hope this doesn't surprise you, given what you may know about agricultural work and what I've talked about previously. But if we go back to the prevention measures and the way to help mitigate potential heat-related illness, we need to think about our laws. So California is one of 3 states in the nation that has written into its law a requirement that employers protect workers by providing water, rest, and shade. There's no federal law, there's only a federal recommendation, but no regulation. So we did an assessment of some data from the National Agricultural Workers Survey, which is a survey of workers in the United States from all regions, and we compared data from California to the rest of the nation. And the survey asks participants whether or not their employer provides water on a daily basis. And the top line, that purple line, are the trends from California, and the green line or the bottom line are the trends from the rest of the nation. And you can see that California overall has more positive responses to the question of if your employer provides water. There's a red dotted line in the middle in 2005 to 2006. That's when the heat standard went into effect in California. And you can see a tiny rise in the positive responses from California and a pretty dramatic rise for the rest of the nation. And I'm guessing that's probably due to some press around the deaths in California and the standard. But if you look, across the board, the rest of the nation is not providing water at the same rates that California workers are, which suggests that if states don't have a law, they aren't maybe providing these preventative measures to their workers. So we wondered what the picture was in Montana. So this last summer, we took a survey of workers in Flathead who were working in the cherry harvest, and we asked the same questions that the National Ag Workers Survey asked. We asked, does your employer provide drinking water to you every day? And does your employer provide toilets to you every day? And the reason we asked about toilets is because we know if a worker doesn't have a place to use the bathroom, he's less likely, or actually she is much less likely to drink water. And we also know that if you don't have access to a toilet, you're 3 times at risk for heat-related illness. So our results from Montana, 99% said that they had access to water every day, and nearly 97% said they had access to toilets. This is great news, Montana. We compared Montana's numbers to some of the numbers from the National Agricultural Workers Survey, particularly in the Southwest. So this is Arizona, New Mexico, Oklahoma, and Texas. And in those regions, only 86% of workers report having access to water, and 84% report having access to toilets. So this is pretty phenomenal. And remember, Montana does not have a law that requires employers to provide these things to their workers. This is a sample from Flathead, and the cherry growers in Flathead are part of a cherry cooperative, and they know that in order to have a harvest every year, they've got to protect their workers. So we're really excited about these findings. Another protection that workers in the cherry harvest have that's unique to them is typically when temperatures reach 80 degrees Fahrenheit, picking stops for the day because the cherries are too tender to pick. And so that's an additional protection for cherry workers. Okay, so here's what we know. Agricultural work might be harmful to the kidneys. We have data from around the world suggesting that something in outdoor agricultural work puts workers at risk for kidney damage. In many cases, because of late diagnoses or poor health infrastructure, this is a fatal disease. We found acute kidney injury over the course of a workday is associated with heavy workload. Heat might still be playing a factor here, especially given what we know about heat and exercise and dehydration. We just didn't see it in our sample. Because of rising temperatures and injury rates, we know that agricultural workers in Montana are at risk of heat-related illness. We can also be very proud of providing our workers water and toilets during the workday. But what we don't know is how these are related to the health of the kidneys. So workers in the cherry harvest work exclusively by the piece. So they are paid by the bucket of cherries that they harvest. And based on the data from California, we know this puts them at risk for acute kidney injury. And we also weren't able to ask about rest breaks. So while it's really great that water and toilets are provided, if we don't know about the quantity and quality of the rest breaks during the day, we don't know if the body is getting enough time to recover from those periods of intense physical activity. So again, logical next steps. And a final next step is to get into eastern Montana and see if the situation matches what's happening in the cherry harvest. So that's what I've got for you today, and I'd love to hear your thoughts. Thanks.
Yeah, very intrigued by the result related to piecework. And I wonder if you have any information about to what extent that's because piecework workers are working more, working harder, or whether they're taking fewer breaks.
So we don't know, but because there was an independent association of workload and piece rate, I don't actually think it's the workload. I don't think it's the harder work.
Okay.
My assumption is the breaks. And nobody's really looked at that. Even in the California Heat Illness Prevention Study, we asked if they were taking breaks, but we didn't ask when and if the employer provided and if it were in the shade, all of those sort of quality of the breaks.
And I wonder, to what extent it's possible that providing breaks may not be enough. You may have to mandate breaks.
Right, and they are mandated, and they're slightly ridiculous. It's, I can't remember the actual numbers, but it's, if the heat, like at one point, if the heat is at a certain level, workers can work for 15 minutes every hour and then have to break for 45. So that's not going to happen, frankly. Yeah, but it is mandated, but whether or not that's being followed, we don't really have good evidence.
You said that older workers were less likely to have damage, right? I wonder to what extent that might be pacing, that you learn how to do it. I think of working in Southeast Montana, and we have people that say, let's go. And I think that in my own experience, if you don't want to ever get hot, it's okay to work many hours in a day, but don't let yourself get hot.
Yeah, that's a very good point. And that could be part of it, actually. Another sort of complicated thing is that workers are sometimes paid by the piece as a team. And so it's the whole, it's a little, especially, if you think of the machismo culture of Latino farm workers, that's like, come on, like we could go home if you work a little faster, or we could make more money if you work a little faster. So there's also some peer pressure when they're paid by the piece as a team. Yeah.
So I'm a guy here from Central Washington. There's a huge forestry, like migrant people, including like lots of cherry trees as well. Just as so, like maybe like just is another way to like sort of like maybe look at like some of the variables that play. Like, is there any similar research that they've done out there that you've been able to find?
Yeah, there is. University of Washington is very present in the Yakima Valley, and they do great research on heat-related illness. And in fact, that what we know about access to toilets came from Yakima. What I'm currently working on is trying to study the kidneys in Yakima, where they've got quite a different climate than Montana. And then, that would inform Montana agriculture, because those are the workers. They come directly from Yakima to work in Montana and then go back.
Oh, because I was know that they have, I know that they have some more positions, but what you're saying, at least from the percentage that you can for like making sure they're getting enough water at the restaurants. Yeah, and it might be.
That's okay. But you're right that Washington does have laws. The Washington laws for outdoor workers are limited to summer months. So I think it's May, maybe to October, maybe September. They're not year round. Yeah.
So I think there's a lot going on, and it's confusing at times. I see a little bit of data that says dehydration, at least in your study. And then in Montana, it was at protective effect, 80 degrees. But then I'm sort of curious about women who don't want to drink water, because if they drink, there might be pee, and they can't because there's no toilets. So they would be dehydrated, but yet you're not seeing dehydration mechanism. So did you see in your analyses where women are differently experiencing the problem versus men? Maybe you said, maybe you did, I just missed that.
No, so we did a previous analysis on half of our sample, and women did have different odds ratios, especially when we did an interaction term between gender and piece rate work. So men who work piece rate are, I can't remember exactly, but it's like 4, odds ratio of 4, and women who work piece rate are odds ratio of 102. So there's quite a difference there in those categories. We didn't see that when we combined both data sets. We also didn't have the workload variable when we separated the genders the first time. And so we're thinking that the workload is sort of absorbing that change or that difference, the gender difference. Interestingly, even though women don't drink as much as men, and we know that, they don't get heat-related illness as much. And, maybe there's a difference in the way that body fat holds water, and women tend to have more body fat. And so that could be part of the protective mechanism. It's unclear, and I don't have good data about that, but that's just sort of some of my guesses.
On the peace meal, you said it was associated with greater muscle breakdown.
Well, I'm presuming.
Oh, okay. And would the mechanism then be if that's happening, you've got chemicals in the body that the kidneys can't clear, and so then you run into trouble.
Right, so that's rhabdomyolysis. So during periods of intense exercise, the muscles break down and those kinases can't get through the tubules of the kidneys. They're too big. And so that produces kidney injury and failure. But you need a serum, a venous blood sample for that. And we had capillary blood samples. So we weren't able to measure kinase. I would assume.
I would too. But
I don't know that I know that, but I would assume it. Yeah.
Interesting to see.
Yeah.
If hydration levels moderate some of that release.
Right.
Or the body is better able to process.
Mm-hmm. That's a good thought. Thank you. Yeah.
With your sample quantification, I might have missed when you're saying this. Are you taking them being identified as dehydration either from blood test or from symptoms?
So actually, we used a change in body mass. So when you're in the field, the easiest and most effective way to do that is to measure participants in base layer of clothing in the morning and then measure them again in the same clothing in the afternoon. And then you subtract. So that's how we did that measure. You can't take a urine sample because if you're looking at kidney injury and the kidneys aren't concentrating the urine correctly, that's not effective. We do have some measures of blood osmolality, but those aren't great because it's like a lag in the response. So we chose change in body mass.
Where did you find the accuracy of that measurement based off of like a normal urine test? Like, granted, you can't use that, but like, is it just as accurate?
It's pretty close. Yeah, it's sort of like the gold standard in field settings. Brian.
You mentioned, wait your turn, Tad. You already asked a question. Wait your turn, Tad. You've already asked a question. You mentioned that AKI is temporary, or like that can be, basically you can have it at the end of the day, show up in the morning, and then it's gone. What's the link then between that and kidney damage? Is there some? Is it that somebody could just get AKI every day? Go back to baseline, get AKI at the end of the day, but as long as, does that just go on infinitely and there is no permanent damage? Or it sounds like the people have died, so.
Right, so actually no, every time the kidney goes into injury, there's a little bit of damage. I mean, you're damaging the proximal tubules. So every time that happens, it sort of happens a little bit, and then eventually you can kick into chronic kidney disease.
And that's not reversible, you think? I mean, can you spend 20 years in the fields and never get into that, what do you call it? What's the last?
Chronic kidney disease?
Chronic kidney disease, yeah.
Brian, we don't know that from an agricultural perspective. Everything we know about chronic kidney disease and acute kidney injury is from studies in the hospital. And so there's acute kidney injury on chronic kidney disease, so you can get acute kidney injury when you already have chronic kidney disease, and you can get chronic kidney disease from acute kidney injury. but we haven't done long-term studies on farm workers. So we don't know if they're going back into regular kidney function. Yeah.
Since sweating should decrease body temperatures, have you or others looked at factors that affect sweating from genetics, salt intake, clothing, and wearing a sweatshirt?
We haven't looked at genetics, and that is an area that's really ready for this particular work because we need to figure that out. We have looked at clothing, and that actually one of my colleagues at UC Davis looked at clothing, and it didn't really have an effect on, we didn't look at sweating. So we looked at heat-related illness, and clothing choice doesn't really have an effect. And it's interesting because some of the laws are, not laws, the recommendations are wear light-colored clothing, wear a wide-brimmed hat, you know, things, sunglasses, things like that, but they don't actually make much of a difference in our California sample. Salt intake is interesting. We haven't looked at salt in particular, but we have looked at sugar. So there's a potential that in the kidneys, the metabolism of fructose changes the structure of the kidneys and creates damage. So we looked kind of a crude measure of sugar intake, a self-report, and then we created a variable of sugar versus water. And we found that in men, no difference, made no difference. But in women, it was a tiny bit protective, but like a very tiny bit. And some of the research out of Central and South America has looked at those oral rehydration salts, those packages, and found that those actually are protective as well. The trouble there is the worker drinking more because they're working harder, and so that's part of it, or is it the actual rehydration salt that's creating the difference? And yeah, the data just aren't, it's not really robust. Exactly. Yeah. Sarah.
I'm making the assumption that the treatment for chronic kidney disease of unknown origin would be the same as chronic kidney disease. So permanent dialysis, long-term dialysis, or kidney transplant.
Yep.
Correct?
Correct. Which is why there are these high rates of death in developed nations, because they don't have those options. Yeah.
Have you looked at other work areas such as like construction, kind of helping people out environmental factors such as pesticide?
No, I love that you suggest that, because it's sort of on the list. But yeah, I mean, that's the theory. Like, could we potentially rule out pesticides if we see this in construction? Yeah.
Since you're not going to ask your second question, I'll ask mine.
Well, I think the genetic thing is very interesting. That I suspect all of us know people who never get hot and who might be paired. It could be a paired design with people who just can't tolerate it.
Yeah, that would be an interesting way to look at that. I was sort of thinking racial and ethnic differences. But yeah, the metabolism of heat is another really good way to position that.
Well, there's still time for you.
Thanks. Have you thought about interactions among pesticides and toxins with heat? Like, could there be some compound either way? I was like, I could see it going either way potentially.
Yeah, and what probably is happening is an interaction of like some sort of weakened kidney and then an exposure of whatever that is, and then damage.
Either way, like heat could be the problem, and then the pesticide could be the problem.
Right. Yeah, I mean, we've thought about it, but again, we don't have the evidence about pesticides. We've only known about this disease for about 30 years. So it's really pretty new, and it's, you know, it's really challenging to study, especially from the United States.
Questions? If not, let's give another round of applause.
Thank you.